let's say that you have 2 jars of cookies, and you go downstairs one night and are looking for a cookie, but let's say it's dark, and you reach out in front of you into one of 2 jars and you pick out a cookie. And let's say that each jar has this breakdown of cookies. So you have, let's say, 10 chocolate chip cookies in the first jar, and you have 1 raisin. And then, let's say in the second jar you have a 100 raisin, and let's say 20 chocolate chip. So the question is, let's say that you reach out in front of you and you happen to grab a cookie, you don't know which jar it came from, and you bite into it and you notice that it's a chocolate chip cookie. So the question is, what's the probability that that chocolate chip cookie came from jar 1? So in mathematical notation, we know that the cookie we have is chocolate chip. So that comes after this vertical bar, it's the condition. And given that condition, what's the probability that it came from jar 1? So this is a conditional probability we're trying to find. Any suggestions? If you're biting into a chocolate chip cookie, what's the likelihood it came from jar 1? Okay, so let's do it both ways. Let's do it building a table first, and then we'll also use the formula. Let's use the table first, because it turns out that the way I drew it here is kind of already in table form, where you have, this is jar 1, and this is jar 2. And then the first row is the number of chocolate chip cookies in each jar, and the second row is the number of raisins. So it's basically already in table form. So if you were to do this, okay, so this is basically already in table form. And we already have the contingency table, and we already have the actual numbers of occurrences, rather than probabilities or percentages. So we can directly just look at this and calculate directly the conditional probability we want. So what this is saying is, out of all the chocolate chip cookies, what fraction of those came from jar 1? Yeah, very good. So out of all the chocolate chip, which is the first row, out of everything in the first row, which is out of 30 cookies in the first row, what fraction of those cookies came from jar 1?
10.
Yeah, 10. So that ends up being our answer. So it's 10 out of 30, or simplified to 1/3, is the probability that a chocolate chip cookie you're currently eating came from jar 1. So it's very tempting to look at jar 1 and say, well, there are 10 chocolate cookies out of 11, so the probability is 10 out of 11. But that's actually the correct answer to a different probability. So what probability is that the answer to? So 10 out of 11.
The probability that you get 10 chocolate chips out of jar 1.
Yeah, so that would be, because in that case, you're known already to be in jar 1. So that means that this condition is that you already know you're in jar 1. So if you're already in jar 1, what's the probability that it's chocolate chip? So that ends up being the 10 out of 11. So you notice that that probability looks very much like the probability we're trying to find, but it's just inverted. So this probability we're trying to find ends up being the 10 out of 30 or 1/3. All right, any questions? So that's answering this question by basically looking at a table. Let's go ahead and use Bayes' theorem, this formula, to find this same conditional probability. So let me write up the formula again. So we'll start with a simplified version of the formula, and then if there's not enough information, then we'll go to the expanded form. So the simplified form is this. So in this case, let's try to determine whether we have enough information for this first. And if we don't, we'll not just jump to the expanded form. So the only difference between the simplified form and the expanded form is the denominator. So the probability of B, in our situation, what would that be?
Probability of chocolate chip.
Yeah, remember, this is the probability we're trying to find. So probability of B would be the probability that the cookie is chocolate chip. So do we know that from this problem?
Yes.
Okay, good. What would that be?
30 over 131.
Very good. So probability of chocolate chip out of all the cookies would be 30 chocolate chip divided by all the cookies. So that would be 30 divided by 131. So we do know this probability. So we can go ahead and just use the simplified version of this formula and not have to use the expanded form like we did previously. So then let's go ahead and expand this out in words first. We're trying to find the probability of jar 1 given chocolate chip So let's first expand out the first probability, which is the probability of B given A. So what would that be in words here?
Probability of picking a chocolate chip
Out of jar 1.
Yeah, so B given A would be chocolate chip given jar 1. So that's this first probability, and then the second one would be the probability of just A. What would that be here?
jar 1.
Yeah, jar 1, probability a cookie came from jar 1. Divided by the probability of B. Yeah, probability of chocolate chip. Alright, so let's go ahead and fill in the numbers. So what would this first probability be? Probability that a cookie is chocolate chip given it came from jar 1. Yeah, so that was what we had worked out over here. So if you know you're already in jar 1, then the probability of a chocolate chip is, cookie is 10 out of the total 11. So that would be the first probability. Second probability is that, this is a little bit tricky, probably a cookie came from jar 1. Yeah, very good. So you would count the total number of cookies, it would be 10 divided by the total. So there's 10 cookies, 11 cookies in jar 1, and 131 cookies total. So probability that a cookie came from jar 1 would be 11 divided by 131. This is tricky because a very tempting answer would be, oh, there are two jars, so the probability that you chose jar 1 would be 1 out of 2. Do you think why wouldn't that work?
There are a lot more cookies in jar 2.
Yeah, this is the probability that a cookie came from jar 1. The probability that an event happened from jar 1. And because these are not equally likely, there's a lot more cookies in jar 1 or in jar 2, I meant. So the likelihood that a cookie came from jar 2 is gonna be much higher than the likelihood a cookie came from jar 1. So because of that, these are not equally likely, so you can't just say the probability a cookie came from jar 1 is 1/2. So this would end up having to be the probability a cookie came from jar 1. Any questions? All right, and then divide by the probability that a cookie is chocolate chip. Yeah, it would be 30 divided by the total, 131. And you can punch this in your calculator to get the answer, but you can also simplify this by hand to get a fraction that's a more precise answer. So this would be on top 10 over 11 times 11 over 131. This is all multiplication and division between numbers, so you can divide first. So you can divide this 11 by this 11. And so this quantity here, this fraction, 10 over 131, divided by this fraction on the bottom. Dividing by a number is the same as multiplying by the reciprocal, or the flip of that number. So we're gonna flip this second fraction here, and now multiply. And again, here, because this is all multiplication and division, you can divide first. So 131 divided by 131, you're gonna get 10 out of 30, which is the same answer that we got from this table. Any questions? Okay. So it turns out in this example, it's much easier to just build a table than the formula. But that's not always true. Sometimes the formula is gonna be easy. So you should be comfortable with both, so that if one looks like it's too cumbersome or tedious, you can switch to the other one easily. Any questions? Okay, so that's base theorem. So it turns out that that's all the material for test 1. In the time we have left, let's talk about the test and let's start reviewing for the test.
Will the test be tomorrow?
So the test will, so I'm gonna talk in detail about that. So first of all, the test will be on honor lock. So that means that you can do it behind a computer anywhere. And you'll have some flexibility on when to take the test. So I'm gonna make the test open Friday morning. So Friday at like 6 a.m. And it'll be due, you'll have some flexibility, so it'll be due next Monday. As long as you do it before class starts, I'm fine with that, but in the past, when I did that, students would often wait till the very end that morning to take the test, and they'd be exhausted and not even come to class. So what I'm gonna do is make the test due early Monday morning, like at 7 a.m. Okay, and so you have this flexible window to take the test. So I'll make the test, I'll give you a lot more, I'll give you a lot more time than you need. So I'll give you 3 hours. And you're not expected to use the entire 3 hours to take the test. You should, so the software that's used to generate this test expects the average student to complete this test in about an hour. So you have a lot more time than you need. Use the extra time to check your work carefully, don't feel rushed. Yeah.
Any questions?
Okay, so you can expect around 20 to 25 questions. And so even though you can take the test anytime in this window, you need to take it in a continuous block. You can't work on it for an hour and then stop and then come back another day. It has to be in one continuous block. You can't take restroom breaks, you can just get up, but the timer will keep running. So devote, so just find any 3-hour continuous window that you have in this period. So you can use, it's gonna be open book. If you're relying on the ebook, then you can just open up a browser tab while you're working on the test, and that'll be fine. So you can open up another browser tab to access the ebook. So it'll be open book, open notes. So the whole point of making open notes is that you don't feel anxiety about having to memorize anything. So the notes will be at your disposal, but don't over rely on notes. So I've had students in the past where they spent the entire time studying on designing the perfect set of notes. Like everything is color-coded, everything's beautiful, but then they're spending the entire test time just flipping through notes because they haven't spent that that study time actually studying the material and actually organizing and structuring the material in their mind. So spend that study time actually studying and structuring that material in your mind. So the notes should really be an afterthought. It should just be a safety comfort blanket if you need it, but it shouldn't be your main test strategy. Any questions? Okay, so students also often ask whether there's a study guide. So often in the past with other math classes, some professors give a study guide where it's basically similar questions or the same questions even, without even different numbers on the test. So basically, professors give a study guide, and the night before, students will just look at that, memorize it or recognize it, and then from that, they'll do great on the test. So I think that's doing you guys a disservice in terms of learning, so I don't do that. So the test is supposed to, any test is supposed to gauge how well you can apply the concepts that you've understood. It's not about recognizing words that you saw from a study guide the night before, and then forgetting about everything a week later. So if I were you guys studying, what I would do, because this test is basically written by the same publishers of the textbook. So basically, there's software that I go through, and the same software that wrote your homework questions is writing the test questions, and I just go through and make sure that the test questions are appropriate. We've talked about it. But the style and the difficulty should be familiar. It's similar to the homework questions you've already seen. So what I would do is I would go through all the homework questions and make sure that you're comfortable with those homework questions. Because it's very easy to go through the homework and just click on help me solve this and not even think about what you're doing. And you shouldn't have done that the first time when you did the homework. But if you did, then this time around when you're actually studying, make sure that you can go through the homework and be comfortable with those questions. So if you add up all the homework questions, there's a fair amount of homework. So I don't expect you to go through and actually resolve every single question step by step. But at the very least, what you should do is be able to look at that homework question and not be overwhelmed and not panic. You should be comfortable knowing, okay, I know that I should take this approach. I should start with the addition rule, and if that doesn't work, I should start with the rule of complements, and so forth. At the very least, you should have that comfort level. If you don't, then that means you have a fundamental lack of understanding. And you should see me, or you should see anybody else at the Learning Lab, for example, for help understanding the underlying concepts. So once you go through and you are comfortable answering all the homework questions, then I think you should be prepared for the test. At that point, I've posted extra practice problems for the test if you feel like you want extra practice. So I've posted extra practice under Canvas. So under Canvas, there's a link around where the syllabus link is, around where the Axis Pearson link is. It says files, so if you click on files, you'll see this link that says extra practice for test 1. So I would recommend this after you're done understanding and being comfortable with all the previous homework questions that was assigned. What I would not recommend is students are conditioned often to expect a study guide and expecting something that is similar to the test. And so some students maybe won't pay attention in class, and then when they do the homework, they'll just click on help me solve this and not think about what they're doing at all. So far, they haven't taken any initiative to try to understand anything. And so now, the night before the test, they'll start panicking. And then they'll look for something that looks like a study guide. And they'll click on this extra practice, expecting that to be the study guide for the test, or the same problems for the test. And because they're not prepared, they'll look at these questions and they'll freak out. And then they'll take the questions to the Learning Lab, for example. And the poor people in the Learning Lab will do the problems for them in front of them. And then they'll just bring that home and memorize how to do all the steps. And then of course they won't do well because now they've just memorized how to do these particular problems and they can't generalize. And then they'll blame me and they'll say that, oh, the test was nothing like the extra practice. Well, it wasn't meant to be. So again, if you understand the underlying concepts from the homework questions, then you'll do well on the test. But don't just treat these extra practice as a study guide.